Okay, so in this video I'm going to have a look at more differentiation, and this time I'm going to have a look at what's called the product rule. So when you have a function in x, for example, multiplied by another function in x, you must use a rule called the product rule. Or well, one of the ways you can do it, you don't have to do it that way. You can multiply out the two functions and do each term individually. However, usually it's easier to use the product rule. So for example, the rule itself is dy dx is going to be equal to u dv dx plus v du dx. So this is the basic rule. So how does this work, or what do these things mean? So let's have a look at an example. Is probably the best thing to do. So let's have a look at y is equal to, we look at a fairly simple one. Y is equal to x to the power of 5 times x to the power of 4. Now this is, as I said earlier, you could just simply multiply these two out and you would get, we'll just do it over here. Let's say you would end up with y is equal to x to the power of 9. You just add the powers here in this case. So you can see then immediately that dy dx is just going to give me 9x to the power of 8. So that's an easy way of doing this, but this is a relatively easy product to do. Now using the product rule here, let's see, we need dy dx. So that's going to be u dv dx plus v du dx. So let's see, do we get the same answer as over here? Now what you need to do here is identify which one is u and which one is v. Usually the first one here will be u and this one here will be v. So we're going to call u x to the power of 5 and we're going to call v x to the power of 4. So let's just fill in the bits and pieces into this formula here. So the first thing we need to do is write down u. Well, u is just simply x to the power of 5. We'll put it in brackets here. Now we want to do a write in dv dx. So in other words, we want to take v and we want to differentiate it with respect to x. So differentiate v here, we would get 4x cubed. 4x cubed. Bring the 4 down, multiply by x, reduce the power here by 1, so we get 3. Okay, so plus v, so we need to write down v here, which is just simply x to the power of 4. And then we want to write down du dx. So we want to take u and we want to differentiate it with respect to x. So this is u, differentiate u here, we get 5x to the power of 4. And that's it. Doesn't quite look like this yet, but let's have a look. See if we can simplify it. We have x to the power of 5 times 4x to the power of 3. Well, 4 ones is 4. X to the power of 5 times x to the power of 3 is, add the indices here, so you get 5, 6, 7, 8. So we get 4x to the power of 8. Plus, here we have x to the power of 4 times 5x to the power of 4. That's 5 times 1 here, which is 5. X to the power of 4 times x to the power of 4. That will give me x to the power of 8. So when you add the indices here, 4 and 4 is 8. So let's see, when we add this, what do we get? We have 4 of these x to the power of 8s plus 5 of these x to the power of 8s. That gives us 9 of these x to the power of 8s, which is exactly the same as what we got over here. Now this is a longer way of doing it in this particular case. But as these functions in x here get bigger, this formula here will work a lot quicker, a lot easier. So let's have a look at another example. So we'll go to white this time. So let's see, y is equal to, let's pick a function. So let's pick 2x minus 3. And we'll multiply that by 3x squared plus 2x plus 5. Okay, so again what we could do is multiply this out. Maybe it wouldn't take too long, but we'd end up with a fairly big algebraic equation there, and we would then differentiate each term individually, and that's fine. But in this case, we'll use the formula here. So let's see, our formula is dy dx is going to be u dv dx plus v du dx. Okay, so let's pick the first one here as being u and the second thing here being v, and we'll just differentiate these. Okay, so our dy dx then is going to be u here, which is 2x minus 3. You just write that down. Now we want to do dv dx, so we want to take v and differentiate it. So if we differentiate v here, we get 6x plus 2, that's it really, plus we want to write down v, which is 3x squared plus 2x plus 5, and we want to now multiply that by du dx, which is just simply differentiating this part here, which is just 2. Okay, so I mean really that's your answer. You could leave it at that, you could multiply it out and see if it simplifies. So you just multiply these two by these two and this by 2 and simplify it out. Well, actually I won't do that. That's this is effectively your answer here. Okay, so I'll do one more of these and I'll leave it at that then. So let's take, go back to white again here. So we've got y is equal to, let's take 2x plus, let's say 2x plus 3 root x plus 5, and we'll multiply that by root x plus 4. Okay, so again we want dy dx, that's going to be u dv dx plus v du dx. Now again I'll take the first one as being u, the second one as being v, and we'll do this. So let's see, I want to write down u first, so that's 2x plus 3 root x plus 5, and then we want to differentiate this part here. Now remember, root x is just simply x to the power of a half. Differentiate x to the power of a half, bring the half down here, you get half x. Subtract 1 from the half, you get minus a half. Okay, so really what you end up with here is when you differentiate root x, you get a half x to the power of minus a half. Now that's just simply a half times 1 over x to the power of a half. So it's a half, and this is x to the power minus a half, that becomes 1 over x to the power of a half. So that just simplifies to x to the power of a half is just root x, 1 over 2 root x. This is a common term that's differentiated, and if you know that x to the power of a half differentiates to 1 over 2 root x, you can just skip all of this here. So anyway, we want to, where are we? This was u, we're looking at the v dx, so we've got to differentiate v here. So we differentiate root x here and we get 1 over 2 root x. The 4 here, that doesn't, that just becomes 0. Now we want plus, we want to write down v, which is root x plus 4. And then I'll just separate that out here. So I'm just going to come down here a little bit. We want to multiply that by du dx. So we've got to differentiate all this here. So if we differentiate 2x, we get 2. Now if we differentiate 3 root x, differentiate 3 root x. Again, I'll just do that, I'll just do it down here. We'll pick a different color here. So we have 3 root x. So let's take 3 root x. Okay, we want to differentiate that. That's just 3 times x to the power of a half. Take the half again, bring it down. It's not equal to it here. It's what we get when we differentiate it, if you like. So it's going to become a half times 3 x to the power of minus a half. So that's just simply 3 over 2, and that x is to the power of minus a half. So then that just becomes 3 over 2. This x to the power minus a half becomes 1 over x to the power of plus a half. So this becomes 3 over 2 root x. So it's the same as this here, but instead of 1 over 2 root x, because of this 3 here, now we just simply end up with 3 over 2 root x. You may have spotted that earlier anyway. So let's go back to our differentiation here. So we have 2, which is what we get when we differentiate this. Our 3 root x, that's going to become plus 3 over 2 root x. And then the 5 here will just disappear. Again, this is your answer, and again, depending on how you want your answer to look, you could multiply all this out, try simplifying it, but effectively that's it. The rest of it would be just algebra, multiplying out and simplifying. And that's it for the product rule.